So what I would recommend doing in a problem like this is notice that this first coordinate in this case is t, because think about how normally we have f of x and you have everything on the right side in terms of x, so like x plus 2. So this is the independent variable, just like here, they're saying it's t. And then the output is p of t. And notice t, whenever we're talking about radioactive decay, this is actually talking about half-life. That's why this is a half here. If something were doubling in its growth, that would be a 2 instead of a half. But this is measured in minutes. So right away, I'm going to look for which one has 4.0746 mentioned in minutes. A does, B does not. I'm going to eliminate that. C does, and D does not. So right away, I've given myself a 50-50 chance here. And let's go back to our triple T document for the math and think about what we just did. We didn't look at the answer options right away. We did something, right? We thought about what the t value is versus the p of t value. And then look at step 3. Once you're certain on one part of the answer, in our case, we knew that the t variable, so that first coordinate, had to do with the number of minutes, we eliminated the answer options that it definitely wasn't, the ones that refer to it as a percent. So now we're down to step 4. We're going to analyze the remaining 2 options and figure out what makes them different from each other. So options A and C talk about the 25 as percent, but more specifically, option A says what percent remain versus option C, what percent decay into other atoms. But notice, even though it talks about decaying into other atoms, it says the function models P, which is the percentage of oxygen atoms remaining. So it's the amount that remains, not that percent that ends up becoming into a sample decay. So the correct answer option is A.